Good afternoon, everyone. Really glad to see you here. So, my name's Simon Thompson. I'm going to take you through the material today, and I want to talk about this section, the challenge and opportunity to bridge the outcome gap with AI. And by that, I mean that we see a huge amount of interest in modern AI on the internet, lots of pundits talking about it all the time. Everybody, I'm sure, has experimented with it in their own lives. Your kids will have experimented with it, your friends will, of course. And I think most people are getting some sort of value out of it. You know, it's a really intriguing thing to play with and to help you with various tasks. But a lot of times we see issues when people actually try to bring this into business processes and really make some money out of it. And I want to explore briefly why that is, what the problems are, what we can do about them, and how to move forward with AI to actually generate real business value. So, LLMs are the engine of modern AI. They're the core technology. It's nothing intimidating about it. It's just a large language model, LLM. Basically, these are things which are trained over all of the text on the internet, all of novels, textbooks, encyclopedias, and they're just trained to predict the next word, right? They're huge neural network, so called, big mathematical structure, just produces a probabilistic prediction of the next word in a query in a response to a query. It's pretty straightforward. Massive scale, huge technological achievement. And the amazing thing is that they produce fantastically interesting answers. And, you know, this is, you can liken this to, for instance, the index of a textbook, a very, very clever sort of index, and you can query this vast textbook of all human knowledge using this structure. And this is extraordinarily valuable, as I've said, but there are problems, and the problems are related to this regularity and likelihood. So essentially, the most probable, the most expected response to a query or to a new situation might not be the correct one. It might just be the retrieval of previous biases, prejudices, or approximations to other knowledge. And there are some very well-known examples where this has happened and caused problems. So, for instance, people tried using LLMs to transcribe medical notes, tried naive implementations, and found that they produced made-up elements in the medical notes, which of course is extremely serious and means that you can't really use them out of the box without modification to do that task. The legal profession has been using LLMs to try to transcribe, not to transcribe, but to try to draft out depositions and legal statements. Now, that's very helpful, I'm sure, but what's happened is that sometimes this is leaked into actual cases, and those leaks through have contained hallucinated case law, and of course that causes an enormous problem if a judge finds out. And even if a judge doesn't find out, doesn't spot it, of course, it's a judgment that then is based on a lie, which isn't going to create confidence in the legal system. And then we've had a number of chatbots for different car dealers, or in this case, Air Canada, where the chatbot's been persuaded, based on an LLM that's the engine for the chatbot, it's been persuaded to take actions such as offering free flights or selling cars for very cheap prices. And these are all disastrous things for the businesses concerned, because there's real economic damage to them, but there's also reputational damage. The other thing I'd just like to make sure everybody remembers is that LLMs also can provide a bit of a security risk, in that if your trade secrets are disclosed to the LLM by an employee, it's possible that those trade secrets would then be picked up and used to train the LLM in the future. The AI in the future would then have the knowledge about your trade secrets in it, and that could be regurgitated to a competitor, so that would be extremely damaging. The other thing is just your employees, people without guidance, without training, using AI, this can be value destroying. It can cause employee churn. It can reduce morale, confuse people, make people feel like they're not valued. So it's not just the technical problem. There are also structural problems we should consider. Okay, LLMs, as I said, the engine of modern AI, these large language models, they're huge, complex mathematical structures. This means that it's not easy at all to predict when they're going to make these kind of mistakes or cause these kind of problems. So we have to try and find other mitigations to help us deal with that. So here are three tactics to mitigate hallucinations. I'll go from left to right. On the left, we have the possibility that an engineer can add a so-called system prompt to the system in which the large language model, the AI, is embedded. And this is just an extra piece of text, an extra query into or amendment to the query to the language model, which contains some repeated specific instructions to keep the responses on track. And this is very commonly done with chatbots. Often they're told to act as a friendly assistant or something. But other system prompts can be very useful as well. So, for example, you can make sure that the system is prompted to always provide a live link to web resources which validate the response it's giving. So you'll see now in a lot of modern chatbots they do this. There's a prompt, there's a link in their responses that you can go to and check what they've said, right? So that's one thing that we can do. We can include a system prompt. Another thing that can be done is that we can put guardrails on the other end to catch the problems, right? So this is typically done by creating some requests to another AI to check the output of the queried AI before it is passed to the user. And it's not being checked for correctness necessarily or to improve the answer in some way, but it's being checked for just some very basic things or fairly basic things. So you can make sure that the answer doesn't include hate speech, doesn't include sexual content or PII data or medical information, right? So that's useful because it kind of gives a safety net and a highly reliable safety net, not perfectly reliable, unfortunately, but highly reliable to protect your business from the LLM doing something that's going to seriously cause problems. Okay, so you've got a safety net there. The final thing, which is a pretty interesting approach that people have developed, is to actually add grounding data, so-called, to the prompt silently, like we saw for the system prompt. This is data which is added silently to any request that's made to the AI. And this data comes from a mechanism that's known as RAG. This stands for Retrieval Augmented Generation. And it just means that what we're going to do is look at the prompt that the user has put in, the request the user has made to the AI. In this case, like I'd like a quick competitor update from, say, an aerospace executive, right? That's the interaction that executive sees to the system, but silently in the background, there's been implemented a RAG system, and it goes off to the company's data, proprietary data, and perhaps looks up the role of the user, the domain that the user's working in, and substitutes competitor for some specific companies of interest. So the key companies that this organization is dealing with. So in aerospace, maybe Rolls-Royce, GE, BAE, Raytheon, and so on. And then goes to a public data set, maybe share price quotes, and sticks some actual real data, today's data, into the query. And this now, for the large language model, becomes something that needs to be summarized and reorganized and represented to the user, rather than knowledge that has to be constructed from thin air, right? So it's no longer creating the answer from whole cloth, so to speak. Instead of that, it's taking the specific information that we have integrated into it with the RAG system, and then stitching it into an answer for its user. And that turns out to be much more reliable and less error prone than you'd see if you just went and just asked the chatbot directly. Now, there's a step beyond this. One of the things with using LLMs is that they're answer systems, they're answering queries that users are making. But what we can actually also do is turn them into agents, so things that are proactive, actually delivering outputs to the users, actual changes in the user's environment. So these are things that are taking actions. So the way this works is that extending the kind of idea you saw with the RAG system, putting things silently into the responses. Here, what we're doing is we're putting tools in the hands of the responses. We're looking at the response coming back from the LLM, and we're using that to actually operate tools that take actions. So a typical thing might be to send a compliance message to a user saying, look, you're not compliant in some process, and then check their response to that. Another one would be if you told an LLM that you needed to get a meeting with some people, and the RAG system provided the meeting slots which were available in their calendars, rather than just picking passively a matching slot, the agent might go to one of the users and ask them to make some time available. It might send a message saying, the boss wants to have a meeting with three of you. I've got a slot on Tuesday that Jeff and Jean are both available for. Sarah, could you just flex and open a slot in your calendar at that time? So that could be a proactive meeting booking agent. And typically, in many systems, agents will monitor processes, detect anomalies, and then propose fixes from their knowledge to the system. Now, this is early technology. It's something that's emerging at the minute. One thing that everybody's discovered is that this kind of freedom of action can create surprising behaviors, and there are lots of stories about people who've empowered their agents to look after their mailboxes, for instance, and then discovered that one tactic the agents have understood for reducing the amount of email that they have to handle is simply to delete the email. A way that we say that this should be mitigated is that if in a process there's a potential for damage, then you need to have the humans in the process in control of that in some sort of meaningful way. So this is a human in a loop system. It has to be in some sort of meaningful way. The final thing that we need to note is that our model risk management processes in banking and financial institutions in general are not really fitted for dealing with this kind of agentic model. So the potential for models to take action isn't really well accommodated in our normal model risk management loops. There's a lot of agility and flexibility in agentic systems, and often model risk management processes aren't either flexible or agile. So that's something that we need to pay attention to. We've seen all of these things, these problems that can occur. One other thing that's worth noting is the fact that employees can become very dependent on using these systems over time. And there are a couple of things to bear in mind here. One is the so-called death by sat nav. problem that's often seen. And this is a photo you can see here, an Amazon van, and it turned out that there was a delivery required to a base on an island in Kent, an MOD base on an island in Kent. And it turned out that the Amazon drivers were given the instruction to drive into the sea to get to this island, and several of them did so, right? They just drove their vans into the sea until they got stuck because they had come to trust the navigation system so explicitly and had been given such hard instructions that they should do so, right? And so pretty disastrous there, as you can see. But then also there have been studies. This is a graphic taken from a study by MIT, and this shows how people's brains are stimulated differently when they undertake different tasks using LLMs or just being asked to do it by themselves. And it turns out that these are radically different ways of stimulating yourself. Now, this is important because over time this could cause companies to end up with an eroded capability to actually spot and correct the errors that AI is making. And so it's very important that actions and consideration are given to prevent this kind of capability erosion over the longer term. Okay, that's all in this section, and hopefully we'll catch up again in the future and cover some more material. Thanks very much. Bye.